question, first we will write down the data that was given. A horizontal curve of 480 meters R is equal to 480 meters and 7.5 meter two-lane road, that is equal to 7.5 meter width of the road is to be designed for a speed. Vehicle speed is 80 kmph was given. The raising of the outer edge of the pavement with respect to the inner edge needed to cater to the mixed traffic condition is, we have to find out the rise. Now, rise is equal to super elevation into b by 2. E we can find out by using E is equal to v square by 225 r. So by substituting this E in over here, we get E is equal to 80 square by 225 into 480 into B is 7.5 by 2. So we will get the answer 0.22. So option B is correct. Option is, a vehicle traveling at 50 kmph was stopped with in 1.8 seconds after application of brakes. Then average skid resistance. We have to find out the average skid resistance F. We know average skid resistance is equal to acceleration by acceleration due to gravity. That is equal to acceleration, we know velocity per time. Velocity we know 50 kmph per time is 1.8 seconds. So we convert it to meters and single uniform units, 50 into kilometers converted to meters by 10 power 3, and hour is 3600 seconds into 1.8. By substituting this A in this equation, we get F is equal to 50 into 10 cube by 3600 into 1.8 into 9.8 per second square, that is equal to 0.8 meter. So option A is correct. Water sample, we have to find out the temporary hardness of the sample. The data that was given is, a water sample on analysis has been found to contain 10.5 milligrams per liter of CaHCO3 twice and 12.5 mg HCO3 twice and 7.5 CaSO4, 8.2 milligrams per liter of CaCl2, 2.6 milligrams per liter of MgSO4. So the temporary hardness is because of bicarbonates present in the water. So bicarbonates are CaHCO3 twice and MgHCO3 twice. It's by molecular weight, we know that 100 by 162 into 10.5 is 6.48 of CaHCO3 twice, and MgHCO3 twice is 100 by 146 into 12.5, that is equal to 8.56. Those two bicarbonates, so by adding these two we will get 15.04 parts per million. So option C is correct. We have to find out the permanent hardness that is present in the sample. From the data that was given above, we know that the permanent hardness is going to be because of the other components that are present in the waters, that is sulfates and chlorides. So we know that by adding all the sulfates and chlorides components in the water, we will find out the permanent hardness. The other components are CaSO4 and CaCl2 and MgSO4. We know the molecular weight of each thing, 100 by 136 into amount of quantity that is present in that liter water, we know that, and 100 by 111 into 8.2, 100 by 120 into 2.6, that is equal to 5.51, 7.38 and 2.16. These are the amounts that are present in the sample of water. So by adding these three, we will get 15.05 ppm. That is equal to option C is correct. Question is, a channel is to be designed by Lacey's theory for a carrying 40 cubics of water. 40 cubics in the sense 40 cubic meters per second, that is discharge through that canal is 40 cubics. The side slope S is 1 and the average size of the bed material may be taken as 0.8. D10 is 0.8 millimeters. From the Lacey's theory, we know the silt factor F, that is equal to 1.75 root D. Effective size of the particle, that is D10 is 0.8. 1.75 root D is 0.8, that is equal to 1.565. What we have to find out is the hydraulic radius of the channel. Hydraulic radius R we have to find out. From the data given above, we have to calculate the velocity through the channel from the Lacey's theory. Qf square by 140 is an empirical relation for finding out the velocity, that is equal to Q is 40 into F is 1.565 square by 140 whole power 1 by 6, that is equal to 0.9422 meters per second. And the hydraulic radius R is equal to 5 by 2 V square by F, that is equal to 5 by 2 V is 0.9422 square by F is 1.565. So by calculating this, we will get the value 1.418 meter. So option B is correct.